Welcome back to the Python short video series. Today we're going to make your programs more reliable by learning error handling in Python. Errors can happen anytime, from dividing by zero to mistyping a variable name. But instead of letting our program crash, Python lets us handle errors gracefully. Let's start by understanding the most common errors you'll encounter as a Python programmer. Zero division error happens when you divide a number by zero. Name error happens when you use a variable that hasn't been defined. Type error happens when you try to combine incompatible types like adding a number and a string. Lastly, value error happens when a function receives a valid type but an inappropriate values like converting ABC to an integer. Errors in Python are objects. Each type of error tells us exactly what went wrong, and if we don't handle them, the program will stop executing immediately, and the interpreter will display the error type and message. Now that we know what errors are, let's see how we can catch them using try and exit blocks. I'll show you how the program reacts when you enter different kinds of inputs. This is the whole code. Now if I enter a valid number like 5, Python runs the try block normally. 10 divided by 5 is calculated and result 2.0 is printed. No errors occur, so exit blocks are skipped. If I enter 0, Python starts executing the try block, but 10 divided by 0 triggers a zero division error. So Python jumps to the exit zero division error block and prints you cannot divide by 0. The program does not crash. Lastly, if I enter a string like ABC, int ABC triggers a value error because Python cannot convert letters to a number. Python jumps to the exit value error block and prints please enter a valid number. Again, the program continues running without crashing. The try block is where Python attempts to execute code that might fail. The exit blocks catch specific errors and allow us to handle each one differently. This makes your program robust, user-friendly, and prevents it from crashing when something unexpected happens. Sometimes multiple errors can be handled in the same way. Instead of writing several exit blocks, you can combine them. Here, both zero division error and value error are handled in the same block. Python checks if any other errors in the parentheses match the exception. If yes, it runs the code inside. Let's say I wrote 0, invalid input or division by 0. Now I will write a string like ABC. Again, the same print. This makes code shorter and easier to read. Now that we've seen how to catch errors with try exit, let's look at a situation where we want to trigger an error ourselves. This is called raising a custom exception. First, we ask the user for their age using input and convert it to an integer using int. This is standard input handling. Next, we check if the age is less than 0. A negative age doesn't make sense logically, so we want Python to alert us. In this code, we manually tell Python to raise an error. Python stops running the program here and shows the message we wrote. In this case, value error, the age cannot be negative. Here. Finally, if the age is valid, the program continues and prints it with you are 8 years old. Raising custom exceptions is useful when you have specific rules or constraints in your program. It lets you enforce rules and provide clear messages instead of letting the program continue with invalid data. You can raise built-in exceptions like value error or even create your own custom exception class for more advanced use cases. For example, you could define a negative age error class and raise it, but for most beginner programs, using built-in exceptions like value error is enough. Now that we've learned how to catch errors and raise our own exceptions, let's try a small practice that combines both ideas. Here's your task. Create a program that asks the user to enter a password. If the password is shorter than 8 characters, raise an exception with a clear message. If it's long enough, print a confirmation message. Take a moment to think about how you do this. Consider, how will you check the length? When you should raise an exception, what message will you show? Let me show you one way to solve this. Remember, your solution could look different, and that's totally fine as long as it works. First, we ask the user for a password using input. This will pause the program and wait for the user to type something. Next, we check the length of the password using length password. If the password has fewer than 8 characters, it doesn't meet our rule. So we raise a value error. Notice the raise keywords. It stops the program immediately and shows the message password too short. This is an example of a custom exception because we are controlling exactly when and why it happens. If the password is long enough, Python skips the raise statement and executes the next line. Why this matters is because using raise allows us to enforce rules in our program instead of letting invalid data continue. Later, you could also wrap this in a try exit block to handle the error gracefully and prompt the user again. Great! Now you know how to handle Python errors using try exit, multiple exceptions, and custom exceptions. In the next video, we'll learn file handling, reading and writing files in Python. Stay tuned!